Welcome back. First, I must share something with you. The students we meet are gems in the raw as they wait to be polished by us. The timid or the bold, the coarse in the mold, shine as a teacher's love unfolds. Of course, that's my little poem, the way in which I think about my students. And then I'm going to share something before I get started. So here we are. Now, in a previous session, I recited some of my poems made by me, the author. I'm going to take an excerpt from two of those and then elaborate by showing some drawings, some geometric drawings as reason and backup for what I said. This one is called Square. Some call me square because I'm rare. My angles are perfect, my figure well kept. Some want to be me with vertices of 90. All sides are equal, yet none are so regal. And so we have a picture of the square. Properties, 4 right angles, all sides equal or congruent. Opposite sides are parallel. Other names we might give to the square are rhombus, parallelogram, and quadrilateral. Quadrilateral means 4 sides. Quadri, 4 lateral sides. Unusual characteristics of the square. The general definition is a quadrilateral with 4 straight sides and 4 right angles. The specific definition, quadrilateral with 4 equal sides and 4 right angles. Now, a rectangle has the same general definition, 4 straight sides and 4 right angles. Hence, a square can be called a rectangle, but a rectangle cannot be called a square. The sum of the internal angles of any quadrilateral are 360. Therefore, each angle in a square is equal to 90, the 4 right angles. The square, like all other parallelograms, has 2 pairs of parallel sides which are opposite to each other. Therefore, it qualifies as a parallelogram. Why can the square be called a rhombus? The definition of a rhombus is a quadrilateral with 4 equal or congruent sides, no more. So a square is a rhombus, but a rhombus is not a square. Nice. Now here's a little bit about the triangle, which is also an excerpt from my 15 little math poems. Square thinks he's perfect, little does he know that triangles are compatible with objects that flow. We have 3 angles, 3 sides too, no diagonals crossing our surfaces anew. Square is only 1, yet triangles are 6. Right, acute, obtuse are part of the mix. Equilateral's supremacy can rival the square. Perfect angles and sides, such properties rare. Isosceles is special with 2 sides equal, so cutely defined that wonderful sequel. Scaling is an oddball with nothing congruent, no sides or angles that make things fluent. Obtuse is just that, obtuse and hard to fit into many tight spaces where acute will be it. So I close my quest. Triangles are best. No polygons as rare, not even the square. So, an explanation about my triangles. The 6 triangles are classified according to the length of sides, 3, and the measure of their angles, 3 of those. Classification by lengths of sides, equilateral, all sides congruent, isosceles, 2 sides equal or congruent, scaling, no sides equal or congruent. So you got 3, 2, 0. Doesn't go from 2 to 1, got to be 0. Now that's by length of sides, equilateral, isosceles, and scalene. And here are some pictures. equilateral, isosceles, and scalene. Now let's go for classification by measure of angles. One right angle and two acute, it's called a right triangle. All angles less than 90, all angles are acute, it's an acute triangle. And the obtuse has one angle greater than 90 and two acute. So that's your obtuse triangle. We go from exactly right, 90, less than right, and greater than right. Fascinating. Thank you. Look forward to seeing you soon.